Hello, I'm Scott Simmons with the Open Geospatial Consortium, better known as the OGC, and I'd like to thank the organizers of today's seminar for inviting me to talk to you a bit about OGC and what we're doing with respect to standardization of GeoPose. First, a little bit about OGC. So what are we as an organization? We're a consortium representing more than 500 organizations that functions as a thought leadership hub on all things related to location. We're also a neutral and trusted forum for discussions on location matters, and we operate as a consensus-based open standards organization. That means every standard we develop is available to you for free. Our members are roughly evenly divided amongst the commercial, government, research, and academia spaces, which is quite valuable for ensuring that our standards are addressing not only those needs of the end users, but also are commercially viable. We recognize this need for interoperability of spatial data a long time ago. Many of you might recall in 1993 when the Mosaic web browser was first released so that we could start exploring the World Wide Web. Within the next year, the OpenGIS Consortium, which is now the OGC, was founded recognizing that there was a need to interoperate on the web as well as exchange content through that medium. We use hundreds of thousands of servers, millions of data sets every day to work with geospatial data for emergency and disaster management, for safety of airline flights, for meteorology, etc. These OGC standards underpin a number of these different solutions that you may use in your everyday life. We do this through a whole series of standards through our services architecture. The architecture developed to handle small, focused standards, some might be a little larger than others, that address particular needs and are bolted together to provide the end-to-end solution you might need. Because today we're talking about augmented reality, we might take this path through our standards architecture. On the left, content stored in a number of data formats is made accessible and provided to you via discovery services, and on the right, information obtained from sensors, be that the camera on your mobile device, its gyroscope, its GPS, etc., are fused with that information brought forward in a format that's suitable for use on an end client application. Some of the examples of standards OGC developed: Augmented Reality Markup Language version 2.0 was the first open multi-vendor AR implementation out there. We published this standard in 2014. In some ways, it might have been a little ahead of its time because it was released in a relatively heavy XML encoding, and so it's not terribly heavily used now. But again, it's informing us on how we want to operate in the future with respect to augmented reality. Kml is an OGC standard. Many of you are familiar with using Google Earth and its ability to place, mark, and provide 3D models in an Earth environment. One of OGC's maintained standards. More sophisticated, the City GML standard used for urban modeling, be that at low or high levels of detail and analysis of those models. City GML also forms the foundation for the OGC Indoor GML standard. That is a standard that provides the ability to navigate indoor spaces as well as interpret indoor information such as the signal strength of Wi-Fi, etc., all in a holistic environment. And finally, the OGC Moving Features Encoding standard, just as it sounds, a way to standardize the position and orientation of any object moving through space over time. Think about that again for what we're going to talk about in a minute with GeoPose, because it is the position and the orientation of those objects in space and time. Well, how do we do this work in OGC? I've highlighted a number of standards for you. The standards program is just part of a larger collection of programs that work together to identify those standards that are best suited for the needs of the community. So any standard developed in OGC might become part of our compliance program, in which we develop tests for ensuring that software built against that standard are compliant with that standard. And we also have an innovation program where we do rapid prototyping and other research to ensure that our standards are suitable for market needs. Specifically, if you look at how the innovation program works across technology readiness levels, we have a number of types of experiments we might operate. Things such as sprints and test beds at relatively low maturity to assess requirements and standardization targets, and then things such as plugfests and operational experiments at the much higher readiness level to test existing software or tools in real-time environments and ensure those standards around which the tools are built are operating as intended for that community. Example of some of these initiatives, we've recently completed one on 3D IoT for smart cities, disasters resilience, routing, so routing of objects moving through space and time, marine limits and boundaries, and work on standards for smart cities. We currently have a number of other initiatives underway, such as our test bed, work on simulation and gaming, highly related to the augmented reality community, 3D data and tiles and container, agriculture use of geospatial data, and even building energy and analytics. I'm sure you can see a number of these different experiments have relationships to what we might be doing in this augmented reality community. All right, well then let's get more detail about what we're doing with respect to GeoPose. So OGC is currently working on a GeoPose standard to provide an interoperable means to express, record, share geospatial position and orientation of real and virtual objects. And that doesn't mean just in augmented reality context. It could be in a virtual reality context, for maps, or any other place where you may want to understand the orientation and position of any object. We want to build this standard to be foundational to any number of use cases. However, for the remainder of the time, I'll talk much more about how it fits into the augmented reality field, and certainly that might be easier for this community to see the relevance of this standard. So to just start with a few fundamental basics here, well, what do we mean when we talk about a pose? If you look at this person in this picture, he's holding up a tablet and looking at a robot. The tablet is sitting at a certain position in space, and it's oriented towards that robot. And so we have those elements that make up its position and its orientation, its pose. Similarly, the robot has its own position and orientation. That position is relative in both relative position and orientation to the observer. And if we go even further, you'll see all the linkages that make up the joints of the robot themselves have their own position and orientation. Each of these are discrete poses. Well, why the GeoPose? Some years ago, I heard General James Clapper describing why that the U.S. government needed a geospatial intelligence agency say, look, everything is somewhere at some time. Right now, we're all sitting in our own homes or our own offices in this webinar. For the third conference, we are all at our own place at our own time. Let's hope next year we'll all be at the same time in the same place. But that relevance, that geo part, is really important to everything we do in our lives. So then what is a GeoPose? Take that pose I just described a short time ago and place it on the Earth. It's quite simple, right? We know exactly where something might be located on the Earth. We know its relative position to other objects that might be on the Earth. And we can GeoPose those objects, put them at their latitude, longitude, elevation, etc. We might look at things that are above the surface, on the surface, or under surface of the Earth, all as relative measures in their position, and then their relative orientation, of course. So then why do this standardization in the OGC? Well, I described a little bit of our history. We know a few things about location, and it's not as simple as it seems. That location part is really, really complex. So let me just give you a quick little story here. We all are aware that the Earth has a surface made up of plates, and those plates are moving at all times. So right now, Australia is moving at a certain rate of speed away from Antarctica. And if you see my little map here, you'll note that that street intersection is slowly but surely creeping north each year as Australia moves away from Antarctica. The latitude and longitude that you measure on a light pole at that intersection is not in the same position today as it was 8 years ago. And so over the course of this illustration, these objects moved almost 2 meters. I'm sure you can imagine many, many use cases where 2 meters is a significant distance. So these are the kind of complexities we have to at least account for and allow for. So when we look at a GeoPose, we want to consider all those levels of complexity, from the very simple, that base target where it's just a position with an orientation, to more advanced GeoPoses, including objects, all the way to objects that are moving, inside objects that are moving, inside objects that are moving, and all changing their orientation, that chaining of relative positions together. All of that complexity needs to be accounted for in the standard. But if we want to make it really, really simple, it's just this. Here's an example of an encoded basic GeoPose. You have a longitude, a latitude, a height, and a means to describe the relative orientation, position, and view of the object. That's how simple it starts. We can make it a whole lot more complex. So I ask all of you to take a look at the GeoPose Standards Working Group information. We're currently developing this candidate standard. You can go to the OGC website and get information on the GeoPose. And if you want to know a lot more about what I told you and all the details about how the GeoPose standard will be developed, there was a webinar just a few days ago, and here's a link to the recording. I'll be happy to provide any of this information to you. So with that, I want to thank everyone today for attending this meeting. Thank you for inviting me to this conference, and I look forward to answering any questions. Thanks. Thank you for inviting me to this conference, and I look forward to answering any questions. Thanks, everyone. If anyone has any questions, I'm happy to answer. I'll hang out here through the end of this session. It's a lot harder to record than to do these things live. So hopefully the information came across fine and my recording skills were not as poor as I thought maybe they were.
Great, Scott. And you laid it out very clearly. So, but if people have questions, Scott is around here for a few minutes. And I really recommend checking out that webinar that Scott linked to. Can you paste that webinar link into the chat so it might be easier?
Yeah, give me a moment. I got to go find it. So while I find it real quick, everyone feel free for questions. This is why my eyeballs are not focused necessarily on all of y'all. My apologies. There we go. Unfortunately, it's a really long URL.
Yeah. Good thing is copy paste and click.
Yeah.
So
we do have, let's see, a couple of questions there. And Jan Erik, you may even be able to state better which software suppliers are most interested in working with the GeoPose.
Yeah, so at the very platform level for the open spatial computing platform, we now have 3 different companies who are implementing support for GeoPose in GeoPose services. So they were previously doing visual positioning technologies, visual positioning services where they use their own setup. But now, as we're developing the standard with OGC, they will be able to provide the response in a standardized way so that you can have the benefit of being able to swap from one service provider to the other. And likewise, for clients that want to connect with the open spatial computing platform, they need to understand GeoPose. So we are setting up an open source example of a client that runs actually in the browsers of smartphones that will be able to connect to the open spatial computing platform and use GeoPose. But that is very like AR-centric. GeoPose can be used in robotics, self-driving cars, in building BIM models for construction and engineering. So there are a wide range of areas where this can be useful. And the standard that OGC is developing has a logical model that can very elegantly convert into other domains that uses poses. So, for instance, aerospace, you have the need to position and orient maybe a robot that is traversing the surface of Mars, and the whole thing can actually be interoperable with the kind of GeoPose that we're using down here on Earth. It can all be linked through different chains of transformations through that logical model.
Thanks, Erik. And I'll speak quickly to Trevor's question about extensions for GeoPose. Conveniently, OGC uses a core and extension model for our standards. And so we typically try to develop that fundamental core that's applicable to many use cases initially, and then extend as necessary. So perhaps even more relevant at the moment is GeoPose being used as a normative part of other standards. So there's an OGC moving features standard, which has a pose element to it, not referred to as a pose, but a more sophisticated GeoPose standard could be used as a core part of that standard. And then as we see other applications of GeoPose, including discussions already had on what's geo, another planet is another georeference system, how might we extend the GeoPose standard for those cases?